9.2 Interior and exterior angles and polygons. So let's look at our warm-up here. The interior angles of a triangle always add up to 180 degrees. So these are all the inside angles that you see here, like this one here, and this one here. All of these angles add up to 180 degrees. So that's kind of your sum of the interior angle rules for triangles. And so we'll need this fact to help us with today's lesson here. And hopefully you remember doing something like this in elementary school, maybe grade 6, grade 7. But yes, that's one fact that we'll have here. And if you want to, you could take a protractor and just measure the 3 angles inside the triangle on your sheet and see that they add up to 180 degrees. Okay, but what about for other shapes? What about all the interior angles or the inside angles of all the other shapes that exist? So looking at this chart we have here, for a triangle, we have a 3-sided shape, and that's one triangle, and we know the interior angles all add up to 180 degrees. But what if you get into a shape with 4 sides? So here I have 1, 2, 3, 4 sides on this shape, quadrilateral. It does not matter the length of the 4 sides, they could all be different lengths. But the idea here is I could take this shape and split it, and I want to find out first of all, what if I take all these 4 angles, what will they add up to? Okay, the way we figure that out is by splitting the shape by drawing a diagonal from one corner to another corner of my shape to show that I have 2 triangles in here. Okay, 2 triangles, triangle number 1, triangle number 2. So for a shape with 4 sides, I can create 2 triangles. And if we know that each triangle has the sum of all the angles adding up to 180 degrees, then 2 triangles means that if I multiply 180 by 2, I get 360 degrees. So the sum of all of the angles inside this quadrilateral, this shape with 4 sides, is the same as the sum of all the angles inside 2 triangles, which is 360 degrees. Okay? What if we look at a shape with 5 sides? So here I have a shape with 1, 2, 3, 4, 5 sides. Now, if I start from a corner here and I draw straight lines to every other corner that I have here in the shape, right, like this. See, do you notice? And I don't have to draw the ones here. There's already straight lines here. But you'll notice that I have now 3 triangles. Okay. Right? The goal is to find, hey, what is the sum of all the angles on the inside of this 5-sided shape? Well, I can look at the fact that I have 3 triangles, right? So a shape with 5 sides, I have 3 triangles. And if each triangle has all of its angles adding up to 180, then if I multiply that by 3, I'm going to get 540 degrees. So all the angles inside my 5-sided shape add up to the same number as all the angles inside these 3 triangles, and that's 540 degrees. Okay, let's look at, well, how many sides does this shape have? 1, 2, 3, 4, 5, 6. 6 sides. Okay, and if I start from one corner, I could draw to every other corner a line. Okay, and to show that, I have 1 triangle here, another triangle here, another triangle here, and another triangle here. 4 triangles. For a shape with 6 sides, I have 4 triangles, and if each triangle has 180 degrees for the sum of all its angles, then when I multiply it by 4, I get 720 degrees. So the sum of all the angles inside 4 triangles is the same as the sum of all the angles inside this 6-sided shape. 720 degrees. Okay. Well, I can't do that for every shape in existence. I gotta create a formula that can help me with any other shape that exists. So what if I pick a shape with any number of sides? We call it n. Okay, any positive number n. All right. Well, how many triangles would that shape have? Let's look for patterns here. For a shape with 3 sides, I got 1 triangle, right? 1. So the number 1 is 2 less than 3, right? 3 minus 1 is 2, okay? Or I could say 3 minus 2 equals 1. What about a shape with 4 sides? I got 2 triangles. Oh, the number of triangles is 2 less than the number of sides. A shape with 5 sides. The number of triangles is 3. Oh, the number of triangles is 2 less than the number of sides, right? The number of sides minus 2 equals 3. The number of 6-sided shapes, 6 minus 2 equals 4. So the number of triangles is always 2 less than the number of sides, n minus 2. Okay? So if you have n minus 2 triangles and each triangle is 180 degrees, then 180 times n minus 2 is going to give you the sum of all the angles inside your shape. Okay? So that's a new formula for us. The sum of the angles inside any n-sided polygon is 180 times n minus 2. All right, let's work it out with some problems here, right? Determine the sum of the interior angles in the polygon with 15 sides. So n is 15. I'm not going to draw a 15-sided shape, but I can do this, right? The sum of the interior angles is 180 times 15 minus 2, which is 180 times 13. Okay, what's 180 times 13? You take a calculator and you multiply 180 times 13, you get 2,340 degrees. Okay. What if you're asked to find the number of sides n, given that the sum of the angles is 5,400? A little bit more complicated, but it's doable, right? You start with the formula. 180 times n minus 2 equals the total sum is 5,400. And what you have here is an equation. And with this equation, you solve for n, your unknown variable. Okay? So to solve for n, you start with reverse order of operations, right? So you deal with you don't deal with the brackets. The brackets is the last thing you do, but you have this multiplication here by 180. So the opposite operation is 180, dividing by 180. And whatever you do on one side of the equation, you do it on the other side as well. So you divide this side by 180. Okay? So that happens when you divide the right side by 180. You get 5,400 divided by 180, which is just 30. On the left side, the 180s cancel, and I'm left with n minus 2. And solving equations, you have to isolate for the unknown variable. So you have to isolate for n. And to do that, I'm going to add 2 to the left side. And to balance the equation, I have to add 2 to the right side. So the minus 2 and positive 2 zero out, leaving me with n. And 30 plus 2 is 32. So this is the answer. And this says that I have a 32-sided polygon, right? The polygon has 32 sides. Okay. Let's look at another example. A Canadian $1 coin, or loonie, is a regular polygon with 11 sides, and it's called an undecagon. This may be the first and only time you hear the word undecagon in your lives, but maybe not. But there is your new word for you, undecagon, a polygon with 11 sides. Now, what does a regular polygon mean? It just means all sides have the same length. That's what it is to be a regular polygon. Okay? Let's figure out the sum of the interior angles of the loonie. Now, this formula works for whether it's a regular polygon or not. I can just, I'll just apply the formula. 180 times the number of sides, which is 11, minus 2 equals 180 times 9. And 180 times 9, when you put that into the calculator, you get 1,620 degrees. Okay, so there is your sum of the interior angles for an undecagon or a loonie. Okay, but what if I asked, well, what is the mesh? So that's the sum of all these angles added together. Now, this being a regular polygon means all these angles are the same too. What is the measure of one of these angles? If they're all the same, then the measure of each interior angle is going to be the total sum, 60 and 20, and you divide by the number of them you have 11. And if I divide by 11, I'm going to get a decimal answer of 147.27. I'm just going to round it to 2 decimal places, approximate that answer, 147.27 degrees. Okay, does the number make sense? Kind of does, right? If you think of a straight line being a full 180, right? 147 degrees is almost 180, right? It's not missing that little bit there, but that number makes sense to me. Okay, so we're pretty good there with that answer. So that's the first part of our lesson, interior angles. We've covered that. let's look at something called exterior angles, right? Exterior angles. Now, if you take like a triangle like this one you have here, a triangle, I'm just going to draw this triangle, highlight this triangle, here it is. But you notice the triangle has some extra extensions, right? If I extend the sides, if I extend this side here, right? Extend it out. I could extend this side out here, extend that out, and extend this side out here, extend that outward. And I can kind of look at the angles that are called the exterior angles. These are the exterior angles out here, outside the triangle, okay? If you're wondering, oh, what about the other side? What about this? Is that an exterior angle? Well, that's a 180-degree angle. We know that. What we're interested in is these ones that I highlighted, the first three here, the exterior angles. Now, what's the sum of the three exterior angles? Is it going to be 180? Well, I can illustrate this to you by going to this website. Okay, this little applet here. Let's do a little exploration. Okay, here's my triangle with the three exterior sides. Okay, what happens? Sorry, three exterior angles. What happens if I take all three angles and I put them together? Whoop, I get a circle. Oh, a circle. A circle has how many degrees? A circle is a full 360 degrees. Okay, let's put that back. What about if I took four sides? Here's a shape with four sides, and here are the four exterior angles for that shape. If I kind of take all the exterior angles, pull them together, I got another circle. There's another 360 degrees. Oh, let's put that back. Let's go to five sides. Here are all the exterior angles for a five-sided shape. Let's pull them out together. Whoop, another circle, another 360 degrees when I add them all up, right? I can go to, let's the biggest side here. I have eight-sided shape. Look at all of these small little exterior angles. But we pull them together and you create another circle, 360 degrees. Okay. The sum of the exterior angles inside of a triangle, 360 degrees. Look at all the exterior angles in my four-sided shape. Add them all up, 360 degrees. Okay, you can even take a protractor and measure these angles too and see for yourself that they add up to 360 degrees. Exterior angles of a pentagon, a five-sided shape, right? You just extend your pentagon sides, you look at the exterior angles, measure them if you want, add them all up, it's going to be 360 degrees. The exterior angle rule is much easier. There's no formula. It's just they all add up to 360 degrees. That's the rule. Okay? So in summary, the key concepts are the interior angles, the sum is 180 times n minus 2. N is the number of sides. And for the exterior angles, the sum of all those exterior angles just sum up to 360 degrees. The full rotation of a circle. How do I know a full circle is 360 degrees? Well, here's a simple way of looking at it. If you think of a 90-degree angle, the 90-degree angle is your L shape. I have another one this way. The straight line here makes 180 degrees. Make another right angle here on this side. Make another right angle again up there, right? 90 here, 90 here, 90 here, 90 here. Add up all the 90 times 4 is what? 360. That's from starting up here, going all the way around a full 360 degrees, full circle, okay? That is 360 degrees. So there's your lesson. Try the exercises on the next page, and we'll meet up again in our next class to take up any questions and do the next lesson. That's it. That's the end of this video.